Good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on density itself. So let's begin with the worksheet. So here is the work. The question is, what is density? So density is next is the dimension of density. So it is from 1 and minus 2 to 0. Next is SI unit of density. It is kg per meter. Next is CGS unit of density. It is gram per centimeter. Next, so now we have a relation that 1 kg per meter cube. So 1 kg is equal to 1000 gram and 1 meter cube is equal to 10 to the power 6 centimeter. So it gives us 10 to the power minus 3 gram per centimeter. Then we have specific gravity, which is ratio of density of body and density of water at 4 degree centigrade, which is 1 gram per centimeter. Then we have dimension of specific gravity. So it is dimensionless or has a dimension m0 l0 2. Next is SI unit of specific gravity. So it is unitless. Next is CGS unit of specific gravity. It is unitless. Next we have a question that a solid body has a mass m, density d, volume d. It is put into a liquid of density d dash completely. Find. First question is apparent weight of solid body in the liquid. So here we can say that apparent weight will be actual weight minus buoyant force. Actual weight will be mg minus f buoyant. M will be d into v into g. Minus buoyant force will be d dash into v into g. That gives F apparent is Vg into d minus d dash. Next is mass of body. So mass is density into volume. It will be dV. Next is the body has a volume of 10 centimeter cube. It weighs 200 gram in air, 150 gram in liquid 1 and 120 gram in liquid 2. Then find. First is density of body. So density is mass by volume. Mass is 200 gram. Volume is 10 centimeter cube. So we have 20 gram per centimeter cube. Next is density of liquid 1. So weight mg will be downward, buoyant force will be upward, normal reaction will be upward here. So we can say that n is equal to mg minus f buoyant, and this n is the apparent weight. So liquid 1 shows apparent weight 150. So normal reaction will be 150 g is equal to 200 g minus g1 into v into g. From here we get the calculations. d1 is equal to 5 gram per centimeter cube. Then we need to find density of liquid 2. So in liquid 2, weight is 120 gram. So we can simply write using this equation that 120 is 200 minus d2v. From here we get 80 is equal to d2v. V is 10 over here, which gives d2 as 8 gram per centimeter. Next is relative density of liquid 1 with respect to liquid 2. So this is d1 by d2, which is 5 by 8. Next is relative density of liquid 2 with respect to 1. So that will be d2 by d1 or 8 by 5. Next is dimension of relative density. So it is m0 l0 t0. Next is SI unit of relative density. So it is unitless. Next is CGS unit of relative density. It is also unitless. Next question is a body has mass m1 in air, m2 in water and m3 in kerosene oil. Then find. Volume here is V. Density of body. So density of body is m1 by V, which I say as d1. Now we need to find density of kerosene oil. So using the concept of apparent weight, we can say that N1 is mg minus F by N. So N1 here is m3g, mass is m1 in air, and buoyant force will be d3 into vg. Using these equations, we have m3 is m1 minus d3 into v. Using these equations, we have d3 into v is m1 minus m3. Using this equation, we have d3 is m1 minus m3 by v. Now v can be written as m1 by d1. So we have density of kerosene oil as m1 minus m3 by m1 into d1. So these are the basic worksheets of on densities which are developed so that you can start working on the process of problem solving skills, and your mind brain system, your thinking process is aligned as per the requirements of the exam. I hope these worksheets will boost your morale and optimize your time and energy for a better results. Thank you and have a nice day.